Hey everyone, hopefully that worked. This is interesting. Um, cool. So this is going to be our first lesson. I've got the iPad set up, so comment if you want me to stop or re-explain anything. You can always email or phone me on Teams, but I don't know how that will work with lag. But yeah, so all that's in place. Cool. Awesome. All right, so we're going to start by recapping the normal distribution that we looked at yesterday. So just to remind you then, we have discrete distributions like this, which we looked at last year with the binomial distribution. And we have continuous random distributions. Both these are random. Continuous distributions, which we started looking at yesterday, which is the normal distribution. So remember, you've got the mean in the middle. You've got mean plus sigma at the first point of inflection. And you've got the mean minus sigma at that point of inflection. Cool. Right, for both of these, area equals 1. So the area under the curve, I can't really point to that, area under the curve is 1 for both, is in terms of like the whole probability is 1. For the binomial distribution, we have x is modeled by a binomial with a n and then p. So our two parameters are p, n, and then p. Remember, n was the number of trials, and p is the probability of success. Success. Cool. All right. With the normal distribution, so we started looking at this yesterday. We have our parameters in this one. So n for normal, x is a normal distribution with a mean of mu, and then we put in not the standard deviation, but we put in the standard deviation squared. Oh god, that's awful. Standard deviation squared, which we obviously call the variance. So we put the variance in, but we use the standard deviation. So that's the key point there. It says sigma squared, but we obviously use sigma in the calculators. So our parameters are mu and sigma. Mu is the mean, and then sigma is our standard deviation squared. Cool. All right, I think there's a bit of lag. I think things have just started, so this is weird. All right, so let's talk about the distribution a bit. So key points of the normal distribution is symmetrical, about the mean. What we mean by symmetrical is that the mean equals the median, which equals the mode. So a distribution is symmetrical if those things are true. There are asymptotes at each end. So if you like, we got our bell curve. Both of these bits are asymptotes. So the probability tends to infinity. Doesn't usually get there, but very quickly it tends towards infinity. And then we have, as I said just now, points of inflection at mu plus sigma and mu minus sigma, which are the points of inflection there. So I can label the whole thing mu plus sigma and mu minus sigma. Cool. So that's the basics for our normal distribution. Cool. All right. So we're going to try and do a basic normal distribution question. So it's saying the average number of minutes spent watching one of my videos is 12 minutes. Hopefully it's a lot longer in real life. And the standard deviation for view time is 4 minutes. So we can write that as a distribution here. X is a normal distribution with a mean of 12 and a sigma squared of 16. So we've got squared of 4, call it 16. Okay, so if I draw my distribution, not too bad. 12 is going to be in the middle. Can I draw that any better? Oh my god, it's hard. 12, just about, yeah. Cool, and we're going to try these questions. So I want to try these on the class Wiz, which is going to be difficult because there is no computer version of a class Wiz, but also on the graphical calculator. Actually, because you guys, we did do a bit this yesterday, let's see. I'll give you a few minutes, I'll give you 2 minutes and see what you guys can do on your own. So let's set this up to 2 minutes and see what you guys can do. Cool. Right. Where have I gone? There we go. Oh, calculator. So, just picked up that some of you guys thought I was going a bit fast there. So, before we do this question, I'll skip back through the other slides just so you can catch up on any notes. So here's the first slide again. Basically, just talking through your distributions. So you got your binomial, got your normal. Yep. So hopefully that's enough time for that one. Second slide, just doing a sketch. So symmetrical means the mean equals the median equals the mode. Asymptotes at each end of our normal distribution. Sorry, asymptotes, not asymptotes, yeah, asymptotes at the end where it curves off, and we've got points of inflection here and over there, which are at mu plus sigma, mu plus mean plus standard deviation, and mean minus the standard deviation. Cool. All right, so that should hopefully be okay. We'll see. I think there's about a minute lag on this, so we'll see in a minute if that was right. Okay, so trying to solve this one then. Hopefully you guys gave it a shot. We're going to have a look on the class Wiz, because the class Wiz has this lovely function that it can plot these as well. So you go to statistics. If you are doing this on the sorry, this is the graphical. If you are doing it on the class Wiz, I will try and show you that in a minute, although it's going to be a bit more prehistoric. So distribution, normal distribution, which is F1. And then all the stuff we're going to use on normal distribution are going to be with F2 or F3. So these, can I draw? Ooh, maybe if I move that. No, I don't think I can. Yeah, F2 and F3. So NCD and InvNorm. So if we click on NCD, we get this screen up ahead. All the data for normal is going to be variable. Not going to use lists for anything. So we're trying to solve this one, x equals 9. Now, the problem is, because it's a continuous distribution, the probability of actually getting 9 exactly is going to be 0. If you imagine measuring everybody to the nearest nanometer, no one's going to have a height of 9. Or if we all hit stop on YouTube at the same time, we're not all going to stop it at exactly 9 minutes to the millisecond. So the actual probability for this one will be equal to 0. And I can show that on the calculator. If I put in a lower bound of, I guess, 8.999999, upper bound of 9, put in my standard deviation, which was 4. Notice I'm square rooting the 16. If 16 is my sigma squared, I need to square root that when I put it into the equation. So put in 4. And my mean was 12. So put those in, and we're going to scroll down. And normally you could just click calc. We're going to click draw so we can actually see what this looks like. So there's my normal distribution. And I don't know if you guys can see. I think I can perhaps zoom in on this. Can you see right it's going to cover me up. Right near the -1 mark, there is a single dotted line, and that's the area we've told it to find. We've told it to find a tiny portion of area. And if you look at the probability, which is right here, we get p equals 7.9 times 10 to the -9. So that's tiny. It's 0.000000075. So probability, we basically round it for 0. So with a continuous distribution like this, the probability of getting exactly a value, so the probability x equals anything, rounds down to 0. So let's just fit that back in. Cool. Right, for the next view though, we can do those on the calculator. So if you click exit, it'll bring you back to the normal menu. We want to look at x is greater than 8. So my lowest value is going to be 8. My upper value, just put something big in. I mean, this is minutes of a YouTube video, so if we put 1,000 in, that should cover everything. The standard deviation stays the same, and the mean stays the same as well. So if we go down to the bottom, again, I'm going to draw this just so you guys have got a nice picture of what's going on. There's the normal distribution, and we've shaded it from 8 onwards. So I'm going to draw this out as well, just so you guys can see what's going on. It's always a good idea to draw these yourself. So here's my distribution. 12 is my mean. We want it to be greater than 8. So if you think, where's 8 going to be? Well, 8's got to be to the left of 12. And we're looking for this area here. Now, because that area is over half of our distribution, we're expecting the probability to be greater than 0.5, because obviously you'd expect this region to be 0.5, so we've got a little bit extra than 0.5. Cool, so if we look at probability again, it's quite small on the screen there, but you can see it's 0.84. And we normally write these to 4 decimal places, so 0.8413 is our answer. Cool. And let's try the next one. So probability x is less than 4. So again, if I do another sketch, put in 12. This time we want less than 4. So we're expecting our probability to not only be small, but it should be less than 0.5. Oh, let's move this calculator out of the way quickly. Oh my god, what am I doing? Calculator, move this. We can see, yeah, the probability should be a lot less than half. Should be a lot smaller this time. So if I put the calculator, oh my god, somewhere else. Let's go through, go backwards, put in my, oh, how have I done that? Um, I've lost half the calculator, but it's not the end of the world. But somehow that's... Oh, oh. Sorry guys, just having a little teething problem here. Size small. Yeah, fixed it. Cool. Right. So if we put in our upper as 4 this time, because we want to be less than 4, so upper is 4, and my lower, well, the smallest length of video you could get is 0, so let's put in 0, and go down and draw it again. See, we've shaded that little tiny region on the axis there, and our probability is 0.0214. Which is much less, so much smaller. Okay, one thing you will notice is the axes on the graphical calculator goes from -4 to 0 to 4, whereas obviously the ones I've been drawing go from to 12. We're going to talk about that possibly today, possibly during our next lecture. There is a reason for that, and we will get to it. Cool. Anyway, hopefully that was slow enough for you guys to copy. We'll find out in a minute. So next question, or next bit. So we happen to know a few probabilities about the normal distribution, and the exam board expects you to know these. So let's draw a nice big, do that again. Draw a nice big distribution. You guys might want to take up half a page for this in your notes. There we go. And I'm going to put the mean in. Actually, let's do that black. Okay, so the first, we're going to label a few different sigmas. So mu plus sigma. Again, I've not really drawn this well because mu plus sigma, as I told you earlier, was where the point of inflection was. So let's try and fit it in properly, draw a good diagram. There's mu plus sigma, and there's mu minus sigma. So if I put dotted lines up to the curve, the probability, obviously the whole thing is 1. So at the moment, the whole curve has a probability of 1. If we look just between those two limits, mu minus sigma and mu plus sigma, the probability of this area is 68% or 0.68. So spread in 68%. Cool. We also know the probability of mu plus 2 sigma. So let's try and fit these in either side. So u plus 2 sigma and mu minus 2 sigma. And the probability for those ones is 95%. So that's saying 95% of our data is between mu plus or minus 2 sigma. Maybe you can draw that on like this. And there's one more. We can also do mu plus or minus 3 sigma, which is most of our data. So if you can fit that on here, mu plus 3 sigma, mu minus 3 sigma. And in that we get 99.7% of our data. Which is the overall majority of our data. Cool. All right. So in science, you'll hear this. You'll say like, oh, it's to 1 sigma of accuracy, 2 sigmas of accuracy. It's saying how far into that normal curve it is. So if you know something to 3 sigma, you know it to 99.7% of accuracy. So let's just make a list of these. So 1 sigma, 68%. 2 sigmas, 95%. And 3 sigmas, 99.7%. Cool. Right, so we're going to try and use those for a question. So make sure you guys got that written down. I will give you a sec now so you can finish copying that. Cool. Hopefully that was enough time. Again, you can always revisit this if you need to. So we're going to try this question about pigs. So the masses of pigs on a farm are modeled as this normal distribution. And it's telling us if 84% of the pigs weigh more than 52 kilograms and 97% of the pigs weigh more than 47.5 kilograms, find mu and sigma squared. So this is quite a tricky question because those numbers obviously don't relate at all to these numbers. So you might be thinking, how are we going to do this? And the answer lies really in a sketch. So if I draw we'll do the first statement first. We've got 84% of the pigs is more than 52 kilograms. So if I, on my diagram, put in 84, put in 52. So if 84% weigh more than this, it says to me that 52 kilograms must be somewhere here on my graph because obviously it's the, oh my god, what am I doing? So yeah, 52 must be about here because all of this area here must be 84%. So we know half of the graph is 50% on either side. So if 84% have more than this weight, more than half the graph must be included. So I know 52 has to be over here somewhere. So let's put that in. Line there, this is 52, and this is 84%. So what's left? What's left as a percentage? Well, 16%. So if we look back at our normal distribution on the last page, and I'm going to get rid of some of my details on here now, or am I? No, let's not. If we look back at this normal distribution, we can see, well, we've got 84 in the middle here, and 16 on the end. Here we had 68 was our first one. If you think about it, if the middle bit, the red bit there, can I move myself? Nope, I can move this. If this bit here is 68%, what's going to be left for each tail? Well, we could do 100%, take 68%, and get 32%. So the total for both the tails must be equal to 32%. So each tail must have 16%. So if we go back here, actually, this one is our 1 sigma accuracy. So we've got 68% in the middle, 16% either tail. Here we've got 16% on this tail. So I can say that 52 equals mu minus sigma. So let's just go over that again. 16% on this tail here. If I look back at the other graph, our 68 one, the red one, if we filled in this bit here and this bit here, those three areas together must make 100%. We know the middle bit 68%, so each corner together must be 32%. So each tail of our distribution must be 16%. So that's what we've got in this case. So I know that that's 1 sigma that they're talking about. So that's one equation. If we look at the second bit, so we've got 97% of the pigs weigh more than 47.5 kilograms. Let's draw it again. And I'll come over here so I can point at things. So again, we've got, what are we saying, 97.5 and more than 47.5. So again, if there's 97%, almost all of this is going to be more than 47.5. So 47.5 must be right over the end here. So let's put that in. There's 47.5. This is 97.5. So what's left? Well, 2.5% you will say. So this area must be 2.5%. So let's go back and have a look on our graph and see if any of these have 2.5% in the tails. So if I get out my blue, so if the middle of this one, the blue bit, yeah, the blue bit which comes out here, that's 95%. So each tail must be 2.5% because there's 5% left over. So I could shade those in blue. This bit here, 2.5%, and this bit here, also 2.5%, which is again the same as our pig question. We got 2.5%. So I know that 47.5 equals mu minus 2 sigma, because 2 sigma is the blue regions of the graph. Cool, right, so I can solve these two simultaneously. If you add them together, we can cancel some stuff out. So if I, should I scrub off some stuff? We've got not got much space. If I get out of the way. So we got 52 equals that, and 47.5 equals mu minus 2 sigma. If I subtract these, the mu's will cancel. So 52 take 47.5 gives me 4.5. Mu's cancel. Sigma minus 2 sigma is going to be sigma plus 2 sigma. So you get 4.5 equals sigma. They've actually asked for sigma squared. So I'm going to square that. You guys can do it in calculators. You should get sigma squared equals 20.25. So that's one of our solutions. And we're going to use put that back in to find our second solution. So if I put sigma back in to the first equation up here, we get 52 is mu take 4.5. So add that back on and I get mu equals, what would it be, 56.5. Cool, right, it's a bit of a weird question, that one. Normally we do all this stuff on the calculator, but there are a few questions where they expect you to know mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. However, if you forgot that in the exam, you could do all this via the calculator. You could put in the area is 16, work out the value, put in the area is 2.5, work out the value. And we're going to get onto that later today. That's called using the inverse binomial, inverse normal function. But yeah, so they can expect you to know those values and use them. Yeah, cool. All right. So what's next? Cool. I think I'm going to set your question now. So we're going to do EG2. And we've got a normal function. I'm going to say that y is normal with a mean of 45 and a standard deviation of 2. Let's write it. Let's do that again. Y is normal, just about fits, with a mean of 45 and a standard deviation of 2. Cool. And we're trying to do 2 bits of this question. I'll write the first bit on this page and then you guys can try the second. Find the probability y is less than 41 or y is greater than 47. So this sounds pretty difficult. What we've got to do, again, always say it, sketch your normal distributions. So if I do my sketch over here, my mean obviously was 45, so let's draw that in. So we want to try and find the probability that y is less than 41 or more than 47. So let's draw those both in. So 41 is obviously going to be to the left of 45. We want to find the probability it's less than that. So let's shade in the thing that we want to find. So we want to find this area, because probability is area. And we want to find 47, this area. So we're going to shade that in as well. So we want to find those yellow bits. We know the whole probability is 1. Yeah, so let's try this one out. So obviously the calculator can't calculate 2 regions at once. The calculator can only do 1 region. So you've got a few choices. You could work out less than 41, more than 47, and add them together. Or the easier way, I think, is to find the area between 41 and 47. So use this is the lower, this is the upper, and we can take away this area from the whole probability, which is 1. So we're going to do 1 minus the probability that y is between 41 and 47. Oops. Cool. So y minus that is, we can work that out on the calculator. So if I bring back my calculator, cool, let's just, let's move it. You guys don't need to see the whole calculator. There we go. Cool. So if we go to exit again, our lower this time is going to be 41 because we want to try and find the area in the middle. So lower 41, upper 47, sigma is going to be 2, and mu is going to be 45. We can get it to sketch it again just so we know we're finding the right area. Yep, so we're finding that bit, and it's found me the area is 0.818, bit around that up, 0.8186. So we're going to do 1 minus 0.8186. Cool. So if I subtract those, a quick way to do this is, I think I've shown this to you guys before. If you want to do one take something really easily in your head, you're going to make every digit add up to 9, and then the last digit add up to 10. So let's go through this. So obviously it's going to be 0 point. What do I need to add to 8 to get 9? 1. What do I need to add to 1 to get 9? 8. What do I need to add to 8 to get 9? 1. And what do I need to add to 6 to get 10? 4. So there's your answer. Cool. Right, I'm just going to show you guys how to do this on the class Weds because I know some of you don't actually have the graphical calculator. This is going to be a bit fiddly, so bear with me for a second. All right, hopefully you guys can see this. Nice dirty calculator. So if we go to menu and then distribution, we're going to go to normal CD. So all these things are always going to be normal CD. Because it's laggy. And what was the lower again? Lower was 41. It's pretty much the same actually. Upper 47. Put in sigma. Sigma was 2. Remember it's sigma first in these, so be careful of that. Mean is 45. You don't get to draw it with these ones. Everything's typed in. Hit equals 8.81859. So 0.8186. And then we're back to where we were before. So that's how you do it on the class Wiz. Cool. All right, that worked quite nicely actually. Okay, you guys are going to try one of these then. It's similar, well, it's the same question, but slightly different. So I'm going to rub out all this. Hopefully that was enough time, I guess. It's hard to tell actually. Hopefully that was enough time for you guys to do this. So I'm going to get rid of all the workings for the previous question. But it's the same distribution we're dealing with. Cool. So you were being asked find the probability that y is less than 44 or between 46.5 and 47.5. Cool. So I'll give you guys, I don't know how long we got. We're doing pretty well for time. I'll give you guys 4 minutes to do that. Let's say 4 minutes. So there you go. And don't forget to sketch it, is my best advice. Hello? Yeah, cool, we're back. All right. Yeah, well done. I know Oliver and Tom, looks like you guys smashed it. A few of you might have since, but as of 2 minutes 40, well done you guys, you got it right. Let's go through this then. So, gonna draw it. I have to draw it, so let's draw it above my head. So, mean is 45. We want less than 44, so that's this area here, or between 46.5. God, that's a bit iffy writing all this. Let's type it. And 47.5 there. Will this work? So we had 44, 45. This is a bit big. Oh crap. Let's still getting used to this. So 44. Mm, um, this isn't ideal. I will say that. Okay, 44. Whatever. Decimal point doesn't matter. 45 was our mean. 46.5. And then we had 47.5. Cool. That's not too bad, is it? Cool. Okay, and I didn't shade it. So we're trying to find those two areas. So we're going to need to do this in pieces, basically. We can't type this all in at once. So if I bring back the calculator, so let's do the lower one first. So we're going to do upper as 44, lower as 0. Everything else is the same because I haven't touched the calculator since the last one we did. And let's draw it. So yeah, same as my sketch pretty much. So we get 0.3085. So let's put that in there. So that's that region. Let's do the next region. So that's between 46.5 and 47.5. Go down and draw it. And we get 0.2120, well, 121, I guess, for that bit. 0.1210 when we're rounding. Cool, so I'm going to add those two bits together. So my probability should be 0.4295. So well done, guys, if you managed to get that. I know a few of you did. Brilliant. Okay, and that's rounded to 4 decimal places. Awesome. Right, so we're going to get you guys to try another one, because why not? So, no, I'm not. Yes, I am. That's a blank slide for no reason. There you go. Could you guys try this one? The answers are on the board, so you'll know if you get it right or get it wrong. Oh yeah, this one's quite tricky, actually. Part A should be fine. Part B, hint, B requires binomial to. So some questions, they can be really nice and give you a normal question that turns into a binomial question. So again, this is worth 5 marks. I'll give you guys 6 minutes, I think, for this one. So let's get the calculator off, get the timer up, and give you 6 minutes. So there you go. Cool. Back in 6. Good luck.
so let's try and go through this one. So got the calculator up again. Let's erase the hints. Cool. Right. So yeah, it's on page 44 if you did want it from the textbook. There's a few similar questions as well for you guys to try later. All right, so we want to do part A is let's get rid of the answers there. Get some more space. So part A, we're looking for probability X is greater than 490. Part A, you can't see it, whatever. All right, so let's go back to my calculator. Again, this will be similar on the class Wiz, it's just you don't get the sketch, so it's slightly less interesting to look at. So lower, so we want greater than 490, so my lower is going to be 490. Yeah, some good stuff going on in the discussion for this. Yeah, lower is 490. My upper, let's put a big number, 10,000, 100,000, whatever. Sigma is going to be 40. Mu is going to be 480. Cool. So first bit, nice and easy. It's only worth 1 mark, and there's a reason. So there we go. And as it says, 0. Is this what I said it was? 0.4013. Good. So a quick sketch as well. Mean 480. There's 490. So we're expecting it to be bigger than less than a half, because obviously a half is this bit. So yeah, obviously this should be less than a half, 0.4. So there we go. Part B then. And this is where it mixes normal with binomial. So naturalist takes a random sample of 30 squirrels. So we've now got X is a binomial with a sample size of 30. Let's get a calculator though. And we want the probability at least 15 have a mass between 470 and 490. Okay, so we need to work out first of all what the probability is. Remember, we put P in there, and then we're asked to find probability X is at least 15. So we want greater than or equal to 15. So this bit here is all going to be binomial. But we need to find the percentage or the probability first before we do that. So we need to go back over to our normal distribution, and we want to find the probability their mass is between 470 and 490. So if we go back to this sketch, get 470 there. So we're actually trying to find out this area here. Now we could just do it again on the calculator, type in 470, 490 and do it. Or we can realize that because it's symmetrical, 490 and 470 are actually equidistant from 480. So this probability we just worked out, this bit in black, is the same as this bit over here. So we could times that by 2, get 0.8026, and take that away from 1. So 1, can you see this? I'll do it in red. 1 minus 2 times 0.4013 is 1 minus 0.8026, which gives you 0. Remember, take them away from 1, make them add up to 9, make the last one add up to 10. So you get 0.197 4. So that's our probability that goes where I've written P. So we can drop that in. In there. And then we've got a pretty easy binomial question to do. So, yeah, this is where it gets different on the class Wiz and the graphical. So on the class Wiz, if you want to do this one, obviously the class Wiz, if I get rid of every bit over here now, the class Wiz only does less than. So only does less than or equal to. If you think we've got a binomial, we're trying to find greater than or equal to 15. So if I call this one 15, we want to find all this area. So for the class Wiz, we need to do 1 minus the probability that x is less than or equal to 14. So you could do that and work it out. On the graphical calculator, which is still on the screen, we can just go to distribution, binomial distribution, binomial cumulative distribution. Our lower this time will be 15. Our upper will be, well, there's 30 squirrels, so the upper is going to be 30. Number of trials, there's 30 squirrels. And our probability is 0.1974. So either method, you should be able to do this. Click calculate, and we get tiny probability, which is it right? It's gone now anyway. 0. What's that going to be? 4.00019. 3, 1, 2, 1, 2, 3, 4. Yeah, I think that's right. I can't remember what the answer was now. Let me just rewind the stream. Yeah, I mean, oh, actually, that is slightly different. Let me double check my workings. I did do the workings last night when I was quite tired, so that does look right to me. Yeah, the other bit's right, so let me just double check this, guys. I don't want to give you the wrong thing. So go back to normal. We're just going to double check that it is actually between 470 and 490. So sigma was 40. That was 480. Draw. Yeah, 0.1974. So just double check the binomial BCD. Did I write it down? I'm sure I did. Oh, well. 470, 490, number of trials, 30. Right, normal distribution, normal. NCD. No, what am I doing? We're talking about distribution binomial. Yeah. Oh, I put this in wrong. So yeah, it should be lower was what was it again? 15, 30. No trials 30. Probability is definitely right. Execute. Yeah, so I must have written the answer wrong earlier. Sorry guys, I'll write that down for my class later so I don't muck it up. 0.00019. It's not far off, but yeah, 4013. Cool. Right, how long we got left? 15 minutes. Good, not doing too badly. So hopefully everyone's all right with that. I'll just check the comments see if there's any issues. Let's correct that. Part B is wrong. Cool, so I just went back in time, corrected it, so it was actually right all this time. Woo, okay. So next up, we're going to start talking about inverse normal. And we talked a bit about this earlier. So inverse normal is when you know the probability. So when you know the probability and you want to find the value. So in other words, if you have a distribution, up till now we've been finding areas, we've been finding probabilities. So now let's say we know the area and we want to find the probability. So we know the area, so let's say this area is 0.75 and we want to find what is A. what is A. So basically to set these up, you could say probability X is less than A equals, in this case, 0.75. And we want to try and find A. So let's try some of that. That's what we mean by inverse. We're working backwards, trying to find the A value given the probability. So here's one I wrote up earlier. If I, yeah, I'll get out of the way, I guess. Where shall I go? Up here. Yeah, that's good. Cool. Right. So for the first one, then we want to draw all of these because it's important to draw things. So if I calculate's a bit rubbish, it's a bit annoying. I can't. Yeah, let's put that there. And we can hopefully draw. No, let's put the calculator down here. Cool. Right. So part A then. So we're trying to find A. I mean, it's the one we had on the board just now. So if I draw this out again, up here. This is the area we know. That's 0.75. We're trying to find out what A is. So we know A must be more than the mean, obviously, because the mean is. So let's just write down this 0.75. The mean is in the middle, and the mean we know is 20. So we're looking for a number that's greater than 20. So it's always a good sketch so you get a rough idea what A should actually be. So on the calculator, if you go back to stats, distribution, normal, you now see we've got the option for inverse normal. So that's, oh my God, what have I done? If I come down here, it's the the third option down here, inv, so that's inverse normal. So if you guys click that, and on the class Wiz, you just have to scroll down to inverse normal. And they're a bit different how they look, these ones. So let's see if we can get them both up on the screen together. Let's do a comparison. So cool. So there we go. Got class Wiz and we got the other one. So the class Wiz, it has area, sigma, mu. That's it. Area, sigma, and mu. The graphical calculator, on the other hand, has tail, area, mu, and sigma. So there's a slight difference between these. The class Wiz can only do less than. So same as in binomial. Class Wiz can only do less than or equal to. The graphical can do everything basically, but it's a little bit hard to set up. So if we go back to the whiteboard. So for this one is asking us for the probability X is less than A. So easily enough on the class Wiz does less than, so we just type it in as it is. So the area is the probability. Let's just write that down somewhere. Area equals probability. So we're going to type in an area of 0.75. Sigma, oh, let's do that on here as well. I'm doing it on the class Wiz first, actually. So class Wiz, type in the area is 0.75, sigma is 3, and mu is 20. Hit equals, and you should get 22.023. Yep, which does make sense. Which does make sense because it's slightly above A. On the graphical, it's slightly different. So we're going to go down to where it says tail. What it means by tail is where the kind of like the end of the graph, the tail of the graph. So I'm shading this bit up here. Our tail is here. So it's the tail of our probability. So our tail is to the left, so that's set up all right already. The area, 0.75. Sigma is 3, mu is 20. And if we go to calculate, we get the inverse normal 22.03. So brilliant. Give us the same answer on both calculators. Right, second one. It's a little bit more difficult on the class Wiz. So I'll show you first of all on the graphical calculator. Let's do another sketch for this one. So if we get rid of what's been done so far. Got a bit of space. So if I draw this one, probability x is greater than a is 0.4. So put the mean in, mean is 20. Probability x is greater than a is 0.4. So where's a going to be on my sketch? Well, the probability is 0.4. So that's less than half of my curve. So there's 0.4. So a must be greater than 20. So we're expecting a number greater than 20. On the graphical then, all we do is we say our tail is now to the right. So hit right for that. Put in the area 0.4. Everything else is the same. Go to execute. And we get A is 20.76. So that's good, nice and easy still. On the class Wiz, it's a bit harder. As I said, class Wiz will only do less than. So instead of using the 0.4, we need to say, well, if that bit is 0.4, then the bit to the left of A is 0.6. So we can say the probability x is less than A is 0.6. Then we can go on the class Wiz and we can use 0.6 as our kind of left tail and we can work it out that way instead. So I'll show you guys quickly. Oops, just turned off the iPad. Hopefully that doesn't ruin anything. All good, cool. So on the class Wiz, so we said, inverse normal this time. And the area greater than it was 0.4. So we're going to use 0.6 as our area. Everything else should stay the same. And we get 26.27. Wait, that's not right because I haven't set it up properly. No, that is right. I think. 22.76. 20.76, yeah, that's right. Cool. So yeah, we can do it on the class Wiz still, but we have to do it slightly differently. So you have to turn it into that. Hope that's okay with everybody. Cool. All right. Part C then. A little bit more difficult. So let's clear some more space. I just realized it's going to run over by 3 minutes because I'm going on real time and you guys will be on lag time. But so we'll finish this and then that'll be it for today. So again, label 20. This time we want probability x is between 16 and a is 0.3. Now I don't know where a is. A could be here, or it could be here, it could be anywhere. So I'm going to put it here for now. It's a guess. The way we're going to approach this one is we're going to find out the red area, and then we can find out a via finding out the red area. So we're going to do probability x is less than 16, find out whatever that is, and then we're going to say the probability x is less than a is all of the blue bit. That makes sense to everybody? So part A, we're going to use standard normal distribution, and part B, we're going to use the inverse. So I bring back the calculator. Again, this is all less than, so you can do this on the class Wiz just fine. So if I make my tail go left again, area is, oh wait, sorry, shouldn't be on inverse there. Distribution, normal, CD. So yeah, lower value is 0. Upper value is 16. Sigma is 3, mu is 20, so that's all good. Do a sketch again. Cool, so my area is 0.09. So the red bit, 0.09. 9, 1. So if I add that to my 0.3, I know that my blue area, if you like, I'll now shade in blue. The blue bit is going to be 0.091 plus 0.3. So in this bit here, we're going to get our area is 0.03912 there. So, and then we can go back to our inverse normal, and we can put in our tail to the left. Our area is 0. That can't be right, can it? Oh, I put a decimal place in the wrong place. 0.3912 mu and sigma and calc, and we should get our cool, yeah. So A turns out is 19.17. So I did actually draw it in the wrong place. If I correct my graph there, it's not wrong. I didn't know where it was. I guessed wrong, but that's fine. So A is actually here. Yeah, cool. So that's right. So this area was 0.3. To be honest, I should have realized that when I got to that stage, but I didn't. But yeah, 19.7171. Cool. Right. I would like you guys to practice before Friday, page 46, because you haven't done much practice. 7, 8, and 9. Answers are in the book. If you need help, use the exam solutions website. Not the type in Edexcel Solution Bank on Google. All the answers are there, and we will start doing the standard normal distribution on Friday. So tune in on Friday, like, share, and subscribe, and I'll see you guys later. Cheers.